Hey everybody, this is Mr. Beckstrom, and today I want to go over an example from section 4.3. This is kind of using the derivatives and the second derivatives to help us graph these curves here. So it says determine the intervals on which the function is concave up or concave down and identify any inflection points. So I think we've done a lot of this in our pre-calculus classes with similar things, but let's talk about what an inflection point is, and then we'll use what we've probably used before, kind of like a test point method in order to do this. So real quick, when we're working with polynomials, we usually get curves depending on the degree of the polynomial. They kind of go up and down, and they have these peaks and valleys. And concavity kind of represents whether it's a bowl that's kind of facing up or it's kind of like a bowl that's facing down. So facing up like this is concave up, down is concave down. And the point like right here where it's changing from concave up and then boom, it changes to concave down, that's a point of inflection. Notice it's concave down, and then right about here, right about there, it's changing to concave up, and then right about here, it changes down to concave down. So those are points of inflection, and we can actually identify those through the second derivative of a function, setting that equal to 0, and then what we can do is we can do test points. And if we do a test point between two of these inflection points and we get a minus, then we know it's concave down. If we get a plus, then we know it's concave up. And we can kind of do the intervals that way. All right, so let's go ahead and get started here. So this should be a pretty easy one to do the derivative of. So the first derivative of this, just using the power rule, is just 4x cubed minus 9x squared, 9x squared. And the second derivative, using the power rule again, so we have a nice polynomial here, it's just 12x squared minus 18x. All right, now the next thing we do is we want to set this equal to 0. And that will find our points of inflection there. So I'm going to factor out a 6x, so 6x. That leaves us with a 2x minus 3 is equal to 0. And that's going to give us x values of 0 and positive 3/2. So these are our 2 points of inflection there, and what I like to do, just kind of used to, is I set up me a little number line here. I've got my 0, I've got my 3/2, and I'm going to check kind of somewhere over there, somewhere over here, and somewhere over there. Now each one of these has a multiplicity of 1, so you should alternate between positive and negative, and now you're just taking some value in between there and putting it into here and seeing if you get a positive or a negative. I usually use my calculator by putting it into the y1 function and evaluating it, but it's not too hard to tell. So if I take a number between 0 and 3/2, like 1, if I put a 1 in here, that's 2 minus 3 is a negative times a positive is a negative, so I know I have a negative in here. If I take a really big number over there somewhere, let's be a positive here, a positive there, so I'll get a positive there. And if I take a really small number, this will give me a negative here, that'll give me a negative there, negative times a negative is a positive. So I'm going to get something like this right here. So I'll get a concave up, concave down, concave up, and those are my inflection points. So the way I'm going to put it in here, it said separate it by commas. So for concave up, so for concave up, we're going to have it like this. So it's going to go, we start with the left, so we're going to go from negative infinity all the way to 0. We don't include the endpoints here when we're talking about either concavity or increasing or decreasing, and then comma, and then we have this interval as well. So that's 3/2 to positive infinity. It's also concave up. And then for down, concave down, we're just going to have that one interval there. So that's going to be 0 to 3/2. And there. And then going to be open intervals. Once again, we don't include the endpoints. All right, that's it. If you have any questions, let me know, and I hope you have a great rest of your week.